Thanks, Sanju, for the kind introduction. First, I would like to thank the organizers for inviting me to give this address. As I mentioned on Thursday, I was looking forward to giving this talk in person since I was looking to for a good excuse to visit this beautiful city of Lisbon again. But unfortunately, I had to cancel my plans at the last minute. So I would like to acknowledge the organizers for their understanding and for allowing me to deliver this talk remotely. I also like to thank, well, actually, well, the attendees. I don't like remote talks myself, so I really appreciate the fact that you're all here. Especially, I think I am the last speaker of the conference, and I'm the last obstacle between you and the farewell reception. So, and I think that you prefer to go for a lovely evening stroll in Lisbon as soon as possible. So, my talk is about uncertainty and how to directly handle uncertainty in control systems and autonomous robotic systems, and in particular, autonomous robotic systems operating in uncertain and stochastic environments. So the last minute, I realized that I have to add the word autonomy or autonomous stochastic system to emphasize the fact, and I think this is appropriate since this is a conference whose scope, I guess, it's informatics and control automation and robotics. So, can you hear me okay?
Yes, we can.
Some echo. Okay, that's fine. All right. So as I mentioned, this talk is about uncertainty and how to handle it. So a lot of you will say, okay, what's the big deal? We know that. Well, I'm not sure how many people know about this, but feedback, right, was developed. I mean, this is the way to handle, feedback, to handle uncertainties with feedback. And this is the main tool. And people have forgotten that. I think most people these days think feedback is to stabilize systems. Yeah, that is true as well. But the original development of feedback control systems by the giants of the field like Wiener, Evans, Bode, and Nyquist in the 40s and 50s was actually to fight uncertainty. And I think most people these days that are young folks that are educated in the era of modern control theory, the state space methods, emphasize stability, are not aware of the fact that feedback originally was to fight uncertainty, all right, and not so much stabilization. Stabilization is important, but the truth of the matter is that it's probably secondary, as most systems are stable. So in practice, for those of you practitioner engineers know this, uncertainty is what kills you. So how do we do that? I mean, what is the classical way that feedback works to handle uncertainty? As you know, we probably have a plan. It goes as follows. You may have some uncertainty.